Hey guys, and welcome back to another A-level further maths revision video. And in this video today, we're going to take a look at integrating hyperbolic functions using substitution. So there's only two questions in this video. What I'm going to start with is just showing the main results that you need. These results are given in your formula book, but it's worth just recapping them, and we'll even show the derivation of one of the results. So let's just jump straight into it here. And first, let's just start by giving the main results. So the first result that you need to be aware of is the integral here. So the integral of 1 over the square root of 1 plus x squared. Okay, so with respect to x here, dx, what would we get? Well, in this case, what we get here is r sine x. R sine x. Okay, and seeing as we have no limits, we need our constant of integration there. And the reason this result holds is because d by dx of r sine x is equal to this result here, this 1 over the square root of 1 plus x squared. Now we can actually prove this result by using a substitution. And the substitution we're going to take here is x equals sine u. Okay. Now, really, to use this substitution, you need to know this basic result. And this basic result you'll see in a moment from the formula book, but I'm going to show you how you actually show this result using the substitution. So if I take the substitution here, x equals sine u, well, when we integrate here with the substitution, we always find dx. So we need dx by du. So we're going to differentiate x here with respect to u. Well, in that case, that would simply give us cos u. So that's cos u. And then here, we simply want dx on the left-hand side, so therefore dx is equal to cos u du. And now we can simply substitute back into our original integral here. So what I actually have now is the integral of 1 over, so this is 1 over, now the square root of 1 plus x squared. Well, x is sine u, so that's going to be the square root of 1 plus x squared, so that's sine squared u, so plus sine squared u, and then dx we know is cos u du, so cos u du. So how do we end up with r sine x here? Well, we need to do a bit of work here, and mainly we need to consider what this denominator can be simplified to. And for this here, you need to remember your hyperbolic identities. So the square root of 1 plus sine squared u, well, that's just a basic application of our identities here. We know that cos, so what would I say here? How would I explain it? Cos u is just simply the square root of 1 plus sine squared u. Okay. And that result comes from the fact that cos squared u minus sine squared u is equivalent to 1, or identical to 1. Okay, you'd add the sine squared u to both sides and then take the square root to get cos u. Okay, so this square root here, we can just simply write that as cos u. So if we write underneath, we're running out of room a bit here. So this is the integral of 1 over cos u, because like we just said here, cos u is equal to 1 plus sine squared u, and this is times by cos u du. So clearly here, if we times the numerator here by this cos u and divide by cos u, they're just going to cancel. Okay, so what I get left with here is the integral of 1 du. So clearly if I integrate 1 here with respect to u, that would just give me u. Okay, plus our constant of integration. But remember, we can substitute back in now for u. If we go back to this line here, where x equals sine u, we can actually obtain an expression for u. And to get that expression, we just need to take the inverse of hyperbolic sine on both sides. Okay, so to get u, we take the inverse of hyperbolic sine here. So therefore u, and this is looking a little bit messy, but u is equal to r sine x. Okay, And then, so u is equal to r shine x. Don't put the plus c there. We put that back in here. So u is r shine x. So r shine x plus c. Okay, and that's how we get our result. So you don't need to actually be able to prove this, but it might come up where you're asked to show it. So it is always worth knowing how to do something like this. So what I'm going to do is just clear the screen. I'm going to write down the main results now, but just so you've seen the derivation of one of these results. There you go. So we clear all this, and we'll write them all down again. So if we write the first one again, so the integral of 1 over the square root of 1 plus x squared dx. Like we already said, this is r shine x. Okay. The next result here is the integral of 1 over x squared, sorry, the square root of x squared minus 1. Okay, with respect to x, this gives us r cos x, so r cos x plus c. The next result here now, the next integral, is essentially a generalization of this first integral here. So this integral is going to be 1 over the square root of a squared plus x squared. And here, the result I get is very similar to this, but in this case we have a generalization now because this is a squared rather than 1. What I get here is r shine of x over a, and then again we need our constant of integration plus c. And we can also generalize this result here, so we integrate 1 over, this time it's the square root of x squared, but rather than minus 1 it's minus a squared. And again, by looking at this result here and this result, you might be able to figure out that this would be r cos x over a. Okay, plus c. So those are the 4 main results that you need to be aware of. Like I said, these are given in the formula book, which you're going to see in a moment, which I know is true for Edexcel, and I assume it's true for AQA and all of the main exam boards, but just so you've seen those results. Okay, so let's jump into these 2 questions here so we can practice these substitutions. So for this first question here, we're asked to show that the integral of 1 over the square root of x squared minus 25 with respect to x is equal to the natural logarithm of 2 plus root 3. And what you can see here in the bottom left is what your formula book will show. Okay, so that's there to help you when answering questions like this. And I would definitely recommend using your formula book for these. So where do we start with something like this? Well, what we do here is we take a look at the denominator in our original question. So this is the square root of x squared minus 25. And we look back at the formula book now in this column here for f of x. And what we want to do is try and match what we've got here in the question to what we've got here for f of x in the formula book. And if you notice here, in this one here, where it's 1 over the square root of x squared minus a squared. So what I can see here then is a squared is 25. Okay? And we're using something of this form. So we know we're going to get something of the form r cos. Okay? So what we can do then is write our integral here from 5 to 10 of 1 over the square root of x squared minus 25. Okay? Like we just said, this is something of the form r cos. So that means the result will be r cos. R cos. It's x over a. So we said a squared was 25. So therefore a is just clearly the square root of this. So a is 5. So r cos x over a. So that's x over 5. Okay. Now we have limits on this integral here. So we don't need our constant of integration. But because we have limits, we need to consider these limits. So our lower limit here is 5. And our upper limit is 10. So now, what I want to do is substitute these limits in here. So, for example, when I substitute the upper limit in here, that's going to be r cos of 10 over 5. So that's my upper limit, so that's r cos of 10 over 5, but clearly 10 over 5 is just 2. So I get r cos of 2. And remember now, we subtract the lower limit here, so this is minus, and that's going to be r cos of 5 over 5, which is just simply r cos of 1. So now we've got r cosh of 2 minus r cosh of 1. That's what we've got up to now. But what we want here to show is that we get the natural logarithm of 2 plus root 3. So clearly for this point here, we need to use the notation that we have for the inverse of the hyperbolic trig functions. And this is given in your formula book, so you don't have to worry about memorizing this, but I'll give the result here. So we're using r cosh x is equal to the natural logarithm of x plus the square root of x squared minus 1. Okay, and all we're going to simply do then is substitute 2 into here, r cosh of 2, and then r cosh of 1. So if we substitute 2 in here first, what I get then for r cosh of 2 is the natural logarithm of 2 plus the square root of 2 squared minus 1. So that's going to be 4 minus 1, giving us the square root of 3. And minus r cosh of 1, so that's going to be minus here. Well, that's going to be the natural logarithm of 1 plus the square root of 1 squared minus 1. So 1 squared is just simply 1, minus 1 gives us 0. So that's the square root of 0, which simply just gives us the natural logarithm of 1. But remember, the natural logarithm of 1 is equal to 0. So all I simply get left with here is the natural logarithm of 2 plus root 3 as required. Okay, so I'm running out of room a little bit here at the bottom, but that's the result we wanted to show there. Okay, so the natural logarithm of 2 plus root 3. So that's the first question there. And I know we didn't necessarily make use of the substitution. We have in a way by getting this result, but we didn't need to find that substitution ourselves. However, like you can see with this question here, sometimes you need to pick the substitution. So let's take a look at this and choose and kind of decide how we choose that substitution. Now the first thing we do here, again, we use the formula book to do this. We take a look at our integral. So if I just write the integral out here from 0 to 3, this is x cubed over the square root of x squared plus 9. Okay, and this looks a little bit different to our formula book. If you notice in the formula book, the numerator is always 1 here. Okay, and here it's x cubed, and I'm going to say it doesn't matter too much. We're more concerned with the denominator. If you want, you can imagine this as being 1 over the square root of x squared plus 9 times x cubed, if that makes it easier for you to visualize. But it doesn't matter. All we care about here is the denominator. So I take a look at my denominator, and again, I take a look at this column here for f of x. So we compare now what we've got here for our denominator to these denominators and see which one matches. So because this is the square root of x squared plus 9, what we do is we match that then, and this tells us now it's going to be of the form r shine x over a. Okay, because what we've got there is something of the form of 1 over the square root of a squared plus x squared. Here, clearly, our a squared is the 9. So in that case, we can also work out a while we're here. A will be 3. Okay, so now that we've figured out what a will be and what form we're going to use, we now need the substitution here, like it said in the question, by using a suitable substitution. So how do we choose a substitution? Well, the substitution, in this case, because it's of the form r shine x over a, the substitution here is of the form x equals a shine u. So that's why we've worked out a, because we need it in our substitution. Because x is equal to a shine u, what we can say then for our substitution, this is going to be x equals 3 shine u. Okay, so that's what we're going to use as our substitution. And that's how we decide. So make sure you take note of this here. This is important. And that's also true if it would have been of the form r cosh, but rather than it being x equals a shine u, it would have been x equals a cosh u in that case. Okay. So we've got x. Whenever we get x and we're using a substitution, we also need dx. So dx by du here, so dx by du, what would that give us? Well, we're going to differentiate here x with respect to u. So that would just simply give us 3 cosh u. But we also just want dx. So therefore, for dx, that that's just simply going to be 3 cos u. So 3 cos u du. Okay, and at this point here now, we have everything we need. But take your time with this question. It is quite a tricky question. At this point here, give it a quick go now, see if you can figure it out. Like I said, it's not the easiest, but give it a go, and then see if you can get the same solution as what we end up with here. Okay, so we're looking to show that we get 18 minus 9 root 2. So what I'm going to do what I'm going to do to start with here is to use the substitution that we've got. Now we know x is 3 sine u. My numerator is x cubed. So in that case, I'm just going to cube x here. So that's 3 sine u times 3 sine u times 3 sine u. So what I get for my numerator is 27 sine cubed u. So sine cubed u. This is all over the square root of x squared plus 9. So that's going to be 3 sine u times 3 sine u plus 9. So I'm going to get 9 sine squared u plus 9. So hopefully I won't make a mistake here. I am very likely to. It's quite a long question, but hopefully not. And then we also need dx here. So we know dx is 3 cos u du. So I've already run out of room, so let's just get rid of that there. Just so I've got enough room here. And just put it on the end here. So dx, we know that is 3 cos u du. Oops, I'm getting this all over the place. That's the 3 cos u du. Okay. So that's fine. And we're timesing by this here. Okay. So now, this doesn't look too helpful at this point. We need to do a bit of work here with our identities again. And it mainly comes in the form of this denominator. Like we saw before, we're going to make use of the fact now that cos squared u minus sine squared u is equal to 1, or is equivalent to 1. And we're going to rearrange that. Now, we're using here, we just know it again, it's like we just said. So using cos u is equal, I'm just going to put equal here, to the square root of 1 plus sine squared u. Then we can simplify our denominator here. In that case, our denominator is just going to cancel with this 3 cos u. We can express this here as 3 cos u. So in that case, this will cancel with this. And what I'm going to get left with here then is 27 sine cubed u du. So this is now equal to the integral from 0 to 3. That's a 0, believe it or not. From 0 to 3 of 27 sine cubed u du. Okay. Like I said, this isn't the easiest question, and there's a few different ways of tackling this. The first thing I'm going to do here is use linearity, and we can take this 27 outside of the integral. So what I get here then is 27 lots of the integral from 0 to 3 of sine cubed u du. Okay. So here now, what I need to do is use a bit of a trick to do this. So hopefully you've seen something of this form before when integrating, like this, where you've got sine to the odd power like this. What I do now is I split this up. So I write this as 27 lots of the integral from 0 to 3 of sine squared u times sine u. So clearly the powers would add up there to give me 3. And don't forget your du. Okay. And again here, there's a couple of different ways of doing it. You can use the identities again. So I could express this as sine squared u. So again, rearranging this expression here, I could use sine squared u is equal to cos squared u minus 1. That's one way of doing it. That's absolutely fine. And what I'm going to do then is that's the way I'm going to take this here. So if I write this on a clean page then, and I'm not going to go massively into the detail of this integral or this actual step here, just because it is quite long. Hopefully this is something you're not, you know, or you have seen it before. So it's 27 lots of cos squared u, shine u, minus shine u. Okay, so like we said, we're just using our identities here. Don't forget your du. And then here, we integrate this expression. What I get now is 27 lots of a third of cosh cubed u minus cosh u. Okay, so as we go along, minus cosh u. And we also need to consider the limits here. So I kind of skipped over this step and saved it for the very end. But don't forget our limits would change here. So I'll write the original 0 and 3 in. But what we have to consider here is what happens when x is 3. So when x equals 3, that's our upper limit. What we get here then is that shine u is going to be equal u is equal to r shine 1. So u is equal to r shine 1. Okay, and this comes back again to our substitution that we chose. So remember, we chose x equals 3 shine u. So x is 3 shine u. So if I said that x is 3, that's 3 equals 3 shine u. Then we obviously just divide by the 3, and then just take the inverse like that. Okay. So that's how we get that value, and then we need to consider the lower limit here, so 0. So when x equals 0. Well, in that case, then we just simply get that shine u is equal to 0. So shine u is equal to 0, because clearly 0 is equal to 3 shine u. We divide by the 3, so we get shine u equals 0, and then clearly, if you evaluate this for u, you just also get 0. So therefore, u is equal to 0. So then our new limits here will be, in this case, our lower limit will remain as 0, and our upper limit here will be r shine 1. Okay, just the new values that we've got for u. So our upper limit is r shine 1, our lower limit is 0. So now that we've got the new limits here, what I need to do now is substitute these limits in. Okay, and again, this gets a little bit messy. It's not the easiest part to do, but let's see what we get here. So now that we've got our limits, let's substitute these in. So I've got 27 lots of a third of cosh cubed u minus cosh u. So we need to substitute our upper limit first into both of these parts here, doing this step by step. Here, what I'm going to do is use the notation that we have. So what we said was shine u, or u equals r shine 1. Right, okay, so I'm getting very mixed up here. So u is equal to r shine 1. So in that case, shine u is equal to 1. Okay. Now, in that case, we're going to use our identities here again. Cosh squared u is going to be equal or equivalent to shine squared u plus 1. So shine squared u plus 1. And we keep rearranging here for cosh u. So therefore, we take the square root of both sides. So I get cosh u is equal to the square root of shine squared u plus 1. And we know the value of shine u. Shine u is equal to 1. So all I simply do then is square this value and add 1 to it. So therefore cosh u is equal to the square root of 1 squared plus 1, which gives me the square root of 2 there. Okay, so 1 squared plus 1 gives us the square root of 2. And now we substitute this in here. Okay, we know what cosh u is, that's root 2, so we can simply substitute into here. So hopefully all this kind of still makes sense. So like we said before, we had r shine 1 as this upper limit. We've simply found what shine u would be, and then rearrange that to be cosh u, and now we can easily substitute that into here, because this is in terms of cosh u. So this is 27 times a third of cosh cubed u. So that's root 2 times root 2 times root 2 again. So in that case, that would simply give us 2 root 2. So that's a third of 2 root 2. Okay, so we'll come back to that in a moment. We'll simplify in a second. And now we minus cosh u. Well, cosh u is just simply root 2, so that's minus root 2. And what I'll do is I'll put this all in a bracket first just so we can see. So that's our upper limit. And now for the lower limit here, well, if we substitute this in, what would we actually get here? Well, a third of cosh cubed 0, well, that's going to give me minus, that's going to give me minus for the whole expression, but that part there, so a third of cosh cubed 0 would be a third, so that's a third, and then minus cosh u, so minus cosh of 0, well, that's minus 1, okay? So here now we need to keep evaluating this. Like I said, this is quite tricky, so I get 27 times all of this expression now. So I've got a third times 2 root 2. So I'm going to write that as 2 root 2 over 3 minus this root 2 here. So minus root 2. And then here I've got minus a third minus 1. Well, that's the same as 1 over 3 minus 3 over 3, so that's minus 2 over 3. So minus 2 over 3 is the same as plus 2 over 3. So hopefully everything makes sense up to now. And then at this stage here, I'm just going to multiply everything through by 27. Okay, so if we do that here, times everything through by 27, what would I get? Well, I'm going to get 18 root 2. So I get 18 root 2. So 2 root 2 over 3 times 27 gives us 18 root 2. Minus root 2. If we times that by 27, would give us minus 27 root 2. And then finally, 2 over 3 times 27 would give us plus 18. Okay. And then at this stage here, we're pretty much done. We can see what we need to get. We need to get 18 minus 9 root 2. And the way we get that is just by collecting like terms. I've got 18 root 2 here, minus 27 root 2. So in that case, that gives me minus 9 root 2. So minus 9 root 2 plus the 18, or we should write it in the form of 18 minus 9 root 2. Okay, as required. So definitely quite a tricky question, and probably took me quite a long time. Feels like a long video, but hopefully that's helped. Like you see, these questions really are quite tricky. There's lots of little things that can catch out, and you need to be really confident overall with hyperbolic functions, the identities, and just general integration. Okay, but that's our result there. So hopefully this video has helped. Like always, any issues or any mistakes that you might spot, it's definitely a possibility. Like always, just leave a comment down below. Cheers.